Have you ever wondered what actually happens when you hit send on an email or tap to watch a video? How does that data magically appear on a screen halfway across the world in just a fraction of a second? It's not magic, it's an incredible journey. And today, we're going to trace that path, step by step, using these amazing 3D models. So let's start with your device, your phone, your laptop, whatever you're using right now. When you send a message, that data isn't sent as one big chunk. Instead, it gets broken down into tiny pieces called packets. Think of it like disassembling a Lego castle to ship it. Each packet is like a single Lego brick, and it gets a special label, an IP address, which is basically the destination address. It also gets a return address, so the other side knows where to send a reply. This whole process is governed by rules or protocols like TCP/IP, which ensures everything is organized and reliable. Now, these packets are ready to travel. Their first stop is your local router. This little box in your home is the gateway to the wider internet. Your device connects to it, usually via Wi-Fi or an Ethernet cable. The router's job is to direct these packets out of your local network and towards their next destination. It is like the local post office that collects all the mail from your neighborhood before sending it off to the main sorting facility. From your router, the packets travel to your internet service provider, or ISP. This is the company you pay for internet access, like Comcast, AT&T, or Verizon. Your ISP operates a massive network. The packets arrive at a point of presence, or POP, which is basically a local access point for the ISP's network. Here, powerful routers look at the destination IP address on each packet and decide the best path for it to take. Imagine a massive, complex highway system. The ISP's routers are the traffic controllers, constantly analyzing the best routes to avoid congestion and get your data moving as fast as possible. This is where things get really interesting on a global scale. If your data is going to another country, it needs to cross oceans. And how does it do that? Through massive undersea cables. Look at this 3D model of the Earth. These lines crisscrossing the ocean floors are submarine fiber-optic cables. They are the backbone of the global internet. These cables, some no thicker than a garden hose, are packed with tiny glass fibers. Your data packets are converted into light pulses that shoot through these fibers at nearly the speed of light. These cables stretch for thousands of miles, laid on the ocean floor by special ships, connecting continents and allowing us to communicate in real time. It's an absolutely monumental feat of engineering. Once the light pulses reach the other side of the ocean, they arrive at a cable landing station. Here, they are converted back from light into electrical signals. These signals are then handed off to the local ISP in that country. This ISP then takes over, directing the packets through its own network of routers and switches. Just like on the sending side, these routers look at the destination IP address and find the most efficient path to get the packets closer to their final destination. Your data might hop through several different networks and data centers along the way. What's a data center? Imagine a huge, secure warehouse filled with rows and rows of powerful computers called servers. This is where most of the internet lives. Websites, apps, cloud storage, you name it. When you're watching a YouTube video, you're not streaming it directly from another person's computer. You're connecting to one of Google's massive data centers. These facilities are designed for incredible speed and reliability, with redundant power, cooling, and network connections. Your packets are now very close. They're routed from the local ISP to the specific data center hosting the service you're trying to reach. Inside the data center, more routers and switches guide the packets to the exact server that holds the information you requested. So, if you sent an email to a friend, your packets arrive at the server that manages your friend's email account. If you're watching this video, your request packets have arrived at the YouTube server that is streaming it. Now, the process happens in reverse. The destination server receives your packets. Remember how the data was broken down into little pieces? The server reassembles these packets in the correct order to understand your request. It's like putting that Lego castle back together. Once it understands what you want, for example, to load a web page, it gathers the necessary data, breaks it down into new packets, and sends them back to you. These return packets embark on their own journey back across the internet. They might not even take the same path as the ones you sent. The internet is designed to be dynamic, always finding the best available route at any given moment. The packets travel from the data center through various ISPs, across those undersea cables if necessary, back to your ISP, to your local router, and finally, back to your device. Once the packets arrive at your computer or phone, your device reassembles them. The web browser, email client, or app pieces together all the packets to display the content. The text, images, and videos all appear on your screen perfectly assembled. And the most mind-boggling part, this entire round trip across continents and oceans through dozens of pieces of hardware happens in milliseconds. It's so fast, it feels instantaneous. So, the next time you browse the web or chat with a friend overseas, take a moment to appreciate the incredible invisible journey your data is taking. From tiny packets of information to pulses of light under the ocean, traveling through a global network of cables and data centers, all to connect us in ways that were unimaginable just a few decades ago. It's a testament to human ingenuity and the truly global system we've built together. Thank you so much for joining me on this digital journey. If you found this explanation fascinating, please hit that like button and subscribe for more deep dives into the technology that shapes our world. Let me know in the comments what other tech topics you'd like to see. Explained. See you in the next one.